Let me share my entire screen. Okay, so is my screen visible? Please let me know once it is. Hmm? Hello.
Yes, it is visible.
Okay, fine. Ah, so welcome to the another session which is on LangChain, and then we are also going to learn today RAG. Okay, it is a combination of both LangChain and RAG. RAG stands for Retrieval Augmented and Generation. I will also explain you briefly after some time what exactly it is and why do we require that to learn in generative AI series, and how useful it is, okay, in real life, uh, with respect to generative AI. And LangChain is a framework which is most widely useful in generative AI field, and it is most important and a must have skill, okay, if you really wanted to target generative AI, because there are a lot of features and all. We are anyway going to disclose all of them. Oh, so as we all know that we are using this Google Colab. So first is set up the environment. Okay, here what I am installing, you please observe. First is LangChain, and LangChain community is different. LangChain is different. Okay, if you want to access all the LangChain relevant things, generative AI thing, then LangChain community is required. Google Generative AI, Fire CPU, unstructured, PyPDF, LangChain, Google Gemini. Anyway, we are using Gemini is LLM. We already discussed about Gemini, Cohere, and all, right. So today we will discuss uh, Gemini only. I mean, we are going to discuss with the Gemini as an LLM, and how we can implement generative AI applications with help of LangChain. All we are going to see now. Okay, so these are all the things I am going to install. Okay, once I install all these things, okay, anyway it will take a few seconds only to get installed if internet is quite fast. Okay, yeah, it got installed. Okay, so let us have a formal discussion about exactly LangChain is. LangChain is a framework. Okay, it is similar to your scikit-learn, NumPy, Pandas. It is kind of a library, but it is a modular framework to build applications using large language models, LLMs. If you want to, uh, you know, use large language model in the backend, and if you want to build a complete end-to-end application, you need a lot of things, right? All such things LangChain will provide in single stop. So we need not to depend on different things to build. For example, let me show you the LangChain documentation so that you will get a very good idea what exactly this LangChain is. You know the chain, right? How chain exactly looks like. Okay, chain images. If you see the chain, okay, this is the chain. This chain, if you see, this is a link, right? This link is going to join by this. Two links will get joined by another one. Correct? So this is what, if we combine all such rings, small rings, okay, then it will be going to be a chain. Correct? Lang chain. Here the chain stands the same, but instead of these rings, what we will connect? We will connect LLM. We will connect another parameter tools. We will connect other things. I am anyway going to show you what all things we will we can all merge together with the help of LangChain. Okay. Otherwise, what happens, for generative AI purpose we have to use one library. For tools we have to use another library. For chunking we have to use another library or another logic. All different things we have to use different libraries. For embeddings we have to use another library, likewise. But if we use LangChain, it is going to be connect everything with the help of LangChain frameworks. Now is that clear, a small understanding? Okay, why do we require LangChain? Is that clear, a small, in an
Yes,
overall?
Satya.
Yeah. So along with LangChain, actually it is having, LangGraph, LangSmith, Lang. Okay. So everything will have its own usage and all. For example, LangGraph, LangSmith, how they will work is monitoring the LLMs. Okay, visualizing the resources and all. But right now it is not that required. We will only going to focus on LangChain. Okay, this is the official documentation of the LangChain. Okay, introduction, tutorials, everything will be available. Very easily conveyable tutorials will be there. Okay, here you can see the lang graph, like I just mentioned before. It is for deployment. Okay, and lang chain is what this is what this we are going to use lang graph, and these are all not now we are going to discuss. Now we will focus on lang chain. Okay, so yeah, and if you go to the tutorials, then it is clearly mentioned here what all it can do and all. If you are very new to langchain, then these things will help you, like chart models, prompts, prompt templates, chart models, document loaders, embedding models, vector stores. Okay, all such things. But anyway, we will see some examples. Okay, yeah, here in simple terms, what exactly langchain, if anybody asks, then this is a statement, then you should provide them. Like langchain is a modular framework to build applications using large language models. It simplifies tasks, like prompt management can be simplified, chaining multiple actions means LLM calling, one option is there, configuration, one option is there. We anyway have seen those things, right? In Gemini, Cohere, first what library should be imported, after that API key should be passed inside the client, after that again we have to use the right model, after that we have to something like that, all differently handled. But here langchain, all can be handled chained together, so that is why it is saying it is simplifies the task. Like prompt management can be simplified, chaining multiple actions, using agents, we can use agents, integrating the tools, we can integrate, we can even manage the memory. All such things today we are going to discuss. Why do we require langchain? Because it handles the orchestration of tasks like retrieval, generation, reasoning. It can do orchestration, when to do what, and after that what should be taken, something like that. Then pluggable architecture to work with various LLMs, vector stores, APIs, tools. For example, a simple example, if you want to understand, if you want to use um, Gemini, then you have to use Gemini SDK. Correct? You have to use Gemini SDK. Yesterday I told you, Gemini documentation is there. We have to refer that and then understand how they write the functions and all, and then we have to use the same functions to achieve any task. Similarly, if you want to work with Cohere, then you have to use Cohere SDK and then Cohere related functions, Cohere way of calling the functions and assigning the prompts and all. And similarly, OpenAI also the same. We have to use OpenAI SDK. But with respect to LangChain, this is all concept of LLM. Inside LLM, you can have an option to call either OpenAI or Gemini or Cohere, no matter what the LLM that you want to call, you can call that using one straight away function. Here you can see chart Google generative AI is a function within the LangChain itself. LangChain Google Gen AI function. If you import that, and you can use this, so that you can use the Gemini, okay, without any hurdle. We need not to depend on again Gemini SDK. We can rely on LangChain itself. Okay, that is what it is saying. Pluggable architectures are there to work with LLMs, vector stores, APIs, tools, pluggable. Okay, this is a simple example you can see from LangChain Google Generative AI library. We can import the chart Google Generative AI LLM. You can call the LLM chart Google Generative AI. Inside that you should pass the right model of Google Gemini, and then Google Gemini's API key. That's it. LLM now got built. You have to use a respective function, like invoke is the function where you can pass your prompt. Here I am writing the prompt like explain LangChain in simple terms, and now we got all the result, AI message result. Here we have the actual output is content. You can see you have to understand how to fetch the value. You can see the value. This is all the AI result. This is all the AI result. Okay, understand and debug everything. Okay, this is all the AI result. Inside this AI result, what all it contains? It contains the actual output of the generative AI. You can see up to where, here up to here generative AI result. What are the remaining things? Here additional parameters. We don't have any additional, that is why 0. Response matches like prompt feedback, block reason, safety ratings. Anyway, we did not pass anything. Finish reason we did not. Okay, so safety ratings also we did not pass. ID, usage metadata. I told that usage metadata will be helpful to fetch the input tokens, the output tokens, the total tokens. Input token details, cached is there is no system or cached. Okay, is that clear? This is all the output of this llm dot invoke. If you want only content, then you should know how to fetch that content, maybe like this. Let me print this first. Yeah, I got the output. Then if you type that dot, yeah, we got the only content. You can see we got only content, correct? We did not get any other values. If you want line by line, you can also write a small string function. Okay, to remove, to replace this slash n with space, or sorry, next line. Slash n is the next line. Okay, you already knew that. Got it? Is this clear up to now? How to use LangChain for Google Generative AI? Okay, you may have a doubt that Yashwant, if I want to use Cohere or OpenAI, then how to use that? Then you can click on here chart models and prompts, or else um, just a second, I will show you where exactly you can refer all such things. In the starting to the LangChain will be like confusing, but once you understand the actual thing, then you will understand the remaining things. Here LLMs, you can see how to cache a model response, how to custom create a custom LLM class. All such things will be there. And um, different LLMs, what it supports, where exactly is that? API reference? No, these are all API reference. Yeah, so this is also good. Yeah, here you will get such things like how many agents are there. Okay, this is going with some alphabetical order, so that is why this is all chains. Inside chain, okay, okay, here we can search anyway. Cohere, if you type Cohere, okay, these are all Cohere related function. Langchain underscore Cohere. If you go to this particular Langchain chain, this is a chain. Okay, and here all Cohere related functions. See, yesterday we have we had seen that summarize chain. Okay, and you can see down chart Cohere. Okay, all Cohere related functions and Cohere related models can be passed here. Okay, if you want to go for OpenAI, okay, you can go ahead and check the OpenAI related things. Now is it clear like what exactly I mean to say? Is it clear with respect to LLMs? Is that clear? Or if you feel confusing, please let me know. Is that clear? How it is working and all?
Uh, can you do it again real quick?
Yeah, okay. So actually what I mean to say is LangChain is, you know, kind of combination of all generative AI related stuff with one library. For example, if you want to do data analysis, you have to use pandas. If you want to build machine learning, you have to use sklearn library. What if you have a single library like Prajwal? Inside that library, you can do the activities of or functionalities of pandas as well as machine learning. Okay, so one library is enough, right? Instead of having two different things, right? So all you need is you have to develop some functions to do the same capabilities of pandas and the same capabilities of machine learning, right? In the same way, langchain is such a library which was already designed in such a way where you can get all types of generative AI things. You can do it here, starting from LLM calling to build a RAG application. RAG, anyway, I will, once I start explaining what is RAG, then you will understand the importance of LangChain. So that if you learn LangChain library means you have to focus on some functions. Library means what? Functions will be there, right? Python functions which was already developed by the developers. For example, if you practice pandas, what pandas contains? It is a library. It is having some functions. If you want to read CSV file, you will have read underscore CSV. If you want to drop the null values, you have a function ready like drop na. Is that clear? So we have many inbuilt features will be there in pandas. Similarly, in langchain also we do have inbuilt functionalities related to generative AI. For example, when it comes to generative AI, first thing what we think about the LLM, large language model. How many large language models are there? There are many large language models. Some models are from OpenAI, some models from Cohere, some models from Llama, some models from Gemini. If you want to use Gemini models in LangChain, how to do that? You have to know what function will help you to call Gemini models. See, langchain underscore google underscore gen AI is the library will helpful in langchain, and this is a function with respect to google generative AI. If you call this function, there you are allowed to use gemini models and then gemini API key. In the same way what I'm discussing, if you are interested to build an application with respect to Cohere, then you have to search Cohere. So this is the particular library where in langchain you have to use, okay, to call the Cohere related models and pass Cohere API inside langchain modularity. Now is that clear? Hmm? What about others? Because if this is clear, then remaining concepts are really easy to understand. If it is confusing, trust me, remaining also will be confused. That is why. What about you, Samreen, Maria? Clear?
Yeah,
Okay. Uh, so Prajwal, now it is clear or is still confusing? Let me know.
I'm I tend to drop my arm to the airport, and yeah, I was listening, but yeah, it's kind of
Okay. So next concept is components of LangChain. So what are the different components? I already mentioned that LangChain has many components and many modularities are there, but not all very. I mean, everything is important, but when it comes to this particular series, immediate actions that you always have to remember is for building any application with respect to generative AI. I have made it in a nice way. Like these are the things are very important. First, these components are really important. Okay, to build very good generative AI applications. Actually, in LangChain there are way many more, but these things are really important and all categorized into these six. Okay, first one is called LLM wrappers. LLM wrappers means here you can understand with an example what exactly I mean to say. Gemini, Cohere, anyway we just discussed, right? So these are the different LLMs we can use with respect to LangChain. I mean, with the help of LangChain, we can call different LLM models. Okay, that is what interface to LLM. We can do that. Then that concept in LangChain is called component is called LLM wrappers. So that means LangChain provides LLM wrappers. Inside LLM wrappers, what are the different models that you can call? Gemini models, Cohere models, all such models you can call. Second thing is called prompt template. LangChain will provide you prompt template option where you can pass the elements inside that template so that you need not to assign a separate Python string. In the last class, if you remember, we have discussed about this template, right? Template learning. So learn from template. Okay. For example, if you have your own predefined template, you have to replace the values dynamically. Okay. So we can do that with respect to LangChain effectively. I will show you with an example. Okay. From there you will understand what exactly prompt template and how to pass the template and how to pass the dynamic variables inside the template. And then chains. LangChain is of chains, right? Chain means it is a sequential actions. I just explained you with the help of chain image. You can see it is a sequential operations linking one together, right? One to one. Similarly, here chains is sequential actions can be taken place. That means example is prompt to LLM we can connect, and LLM to output we can connect, something like that with the help of LangChain. And then memory. Okay, it is coming up with beautiful memory options. I will anyway will explain you a little later once the topic comes. So it is having some options of memory as well, so that we can build applications like chatbots, all such things. Yeah, it is also coming with tools. Yesterday I had given a glimpse, right, of tool like Google search results. Yesterday we developed a small application, right, if you remember. um, so in that application we used real time Google data, correct? So we enabled that tool. Such tools we can use like calculator, search. Such tools we can use. Many tools are there. The count is limitless because every time they are adding new tools. For example, if you go ahead and see tools, okay, if you search that, see there are many tools are there already. Okay, LangChain community tools. If you go to LangChain community tools, like many tools they are keep on adding. Instead of writing our own code from scratch, we can use whichever already there. If you whatever your expectation, if it is not there in the LangChain tool, then you can develop your own. Okay, something like that. Okay, then agents means something like, see, multi-tool reasoning. This is an example for an agent. There are likewise you can come up with many agents. Anyway, what exactly agent also I covered in the later part of this session. Okay, that is simply the purpose of the agent is LLMs. We want, if we want LLMs to think and then make decisions, then agents will be required. Okay, yeah. Going little further, so this is anyway I have told you in the initial of this LangChain, we are going to use the complete LangChain LLM as Google Generative AI, because Google Generative AI, yesterday I told you, it is free to use till 1 million tokens for one model. Okay, I am using Gemini 2.0 Flash. Okay, and I'm using the same API key which I used in the last class. And if you want to use, after my session, if you want to use Cohere, you please go ahead and see the Cohere related functions and then use the same. Okay, got it? You can do that. Okay, so now we will see how we can use a chain with Gemini. See, now we are going to use a prompt template, and we are going to use LLM anyway. I already assigned it is a Gemini LLM. Okay, Gemini model. So now I want to connect these two, the prompt template plus LLM, like this. In chain we have one circle and one more circular element. These two circular elements, now we need one more thing to club these two, right? Chain. The same way what we are going to do is, we have components, right? Components of LangChain. Remember this always, the components of LangChain. First component is LLM wrapper, something like one LLM model. Second component is prompt template. Now we are going to merge, or else now we are going to build a chain between these two. Okay, this is a different component and this is a different component. Now how to build these two like together as a chain? For that purpose I need an element chain. Okay, we have to import the chain from chains. Okay, langchain dot chains dot import LLM chain. Okay, so if you want to have prompt template, then it is all existing in langchain core dot prompts. You can import the prompt template. Okay, prompt template is something like this. Earlier, without prompt template, what is the use case is, what was the use case? If we, let us consider, if we don't have any prompt template, then how to handle that? For example, remember, this thing we already discussed in the last class. Template, we have to assign a variable template and then use the f string. Okay, we have to use the f string. There we have to something write, like for example, name is Yashwant. Okay, place is something like place. Okay, and if you have any defined variables, like name is equal to, we have to assign and then the name. Okay, sorry. Yeah, so name, we have to enter name, because this is what I want to replace, right, in my string. Similarly, place, let me give original place, Bhimavaram. Okay, so if you print template, okay, if you print template, then those values will get replaced, like see Yashwant is a person from Bhimavaram. Okay, is that clear? So template is something like, we want to use an f string. It is an f string. Strings concept I already explained. This is an f string. So wherever you want to replace something, like you can assign and then replace. Okay, so earlier what we did, we decided something like this template, and then we formed this template inside the prompt. If you remember, prompt is equal to, okay, again f string. So you have to fill this template, something like that, and then template. Okay, now if you print prompt, what will happen? You can see you have to fill this prompt, and then where exactly template is there, this entire template will get replaced here. Try to understand. If we, this is how we have to pass a template inside the prompt, so that it will understand, okay, this is a structure I have to follow while responding to the any inputs, and how exactly I need to provide the output. It will understand a proper format. It can be understand like that. Okay, if we scroll down in LangChain, how can we define a prompt template? Means there is direct function available, that is what prompt template. Inside the prompt template, from template you can use, and then here you can pass the same f string. Whatever the curly brace you are passing, you want to replace, that you have to invoke and pass the dictionary like this. For example, if you have multiple things, okay, if you have multiple things, like explain concept in how many characters. Okay, like for example, in something like this. Okay, then how many curly braces are there in this template? There are two curly braces, right? Then you have to use dictionary with two different keys and values. For example, words. Okay, words, and then pass that words is 150 or 100 or 10. Is that clear? Now if you run this, you will get the output. Embedding, explain embedding concept in easy 100 or in easy 10. Something we did not clearly mention here, 10 words. That is why. Okay, see, representing words, things are numbers, capturing their meaning and relationship. In 10 words only I told. Okay, now is it clear how to pass a template to the LLM? Now we are chaining, you can see here we are chaining with both LLM and prompt. These two things we are chaining. Is this clear till now? Anyone? Samreen or Mushraf or Maria or Prajwal? Is it clear? Like how we are changing?
Ye-
Yes, Ashwant.
Clear?
Yes.
So similarly, let us consider a small example. Okay, so that any doubt if you have, that will go away. See what I am going to do now. My plan is, you can, you, that is all Python. If you know Python, small Python strings, you can do this thing in an effective way also. You can call a small template, a variable template. Okay, if you have any template like this, something like this, that is one way. Another way is directly you can pass inside here. Okay, so simple way, let us understand in simple way. If you want to write any letter, okay, that letter should have some letterhead, right? So let us consider the letterhead like this. Okay, so welcome, or else uh, what we can say, okay, let us do like this: welcome to AI long term course, course. uh, the question, after that at the end we can say, okay, question is, question, explain. Now you understand here how many dependent variables we need. Here concept is there, you can write concept concept in simple words. Okay, array, I'm not getting the proper idea. Okay, we will do one thing. Who is who is prime minister minister of country? Okay, so I have to pass country, and then it will be the question of who is the prime minister of that particular country. How many states, no, 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 uh, who is the, will you give me any idea? Now I'm not getting proper idea. Questions I'm not getting. Anything that you want to
Like
give?
what? Okay. What is the total area of Russia?
Is the area, no, area of the country? Okay, country anyway we are providing. Who is, I want at least three input
Okay.
parameters to pass. One is country. Any other thing, dynamic
Okay.
parameter? Hmm?
Yeah. What is the biggest ship?
What is the biggest, huh?
Yeah, biggest ship.
Ship? No, no, no. What I mean to say is, if, okay, uh, who is the prime minister of the country, and then um, what is, explain explain about subject in 10 words. Okay, and then what is the uh, what is the explain about this company. Okay, how many parameters that I should pass here inside this invoke? Anybody?
I guess three.
Okay, what are them? What are they? One is country, right? I have to give what exact country?
Okay.
India maybe. Then
It's Q UK.
subject. Okay, subject is maybe data science, or I will give data engineering. Engineering. Third thing is company. Okay, any
It,
confusion? Any confusion? No clear? So now we have to pass this
yes.
thing. Actually, we have to pass this control X inside here. Otherwise, it will throw us an error. Okay, so you can use a triple string here, no problem. That is multi-line string. Okay, don't confuse. This is a multi-line string. If you have a string which is more than one. Okay, now you call. Now it is giving this. Country is India, subject is data engineering Infosys. Then okay, here are the answers to your questions. Who is the Prime Minister of India? Narendra Modi. And explain data engineering in 10 words. It is building, maintaining pipelines of reliable things. And then explain about Infosys. Yeah, Infosys is a global IT company and consulting company. Okay, and this is the way how it writes. And if you want to pass a specific predefined prompt, if you observe, we did not get any welcome to AI long term course here, right? Anybody observe that? Because we did not pass again a prompt thing into any specifically here. We have to mention that very clearly. Yesterday I told, right? So in prompt engineering we have to mention very clearly, follow the below template and answer the following questions. QUESTI questions. The response should start with, okay, so put a star, double star. Remember, double star means it will remember. So okay, from it is kind of a quotation marks. Okay, so welcome to, okay, it will understand this, and then question and then answer. Okay, now observe this one. Okay, see, now you can see, welcome to the AI course. Then Prime Minister of India is Narendra Modi, something like that. Now is it clear? Is that clear? We did not pass that thing in prompt, so we want this as a template. Is that clear? Now we have passed, and then can I get a quick response? By default, if you can see,
Yes.
it is returning the JSON way. Okay, that is one more good thing. Okay, so this is all about chaining. What we did, let us recap. So first concept what we covered is how we can use one particular LLM like generative Gemini with respect to LangChain, how to use. We have to call the particular thing and then use the model and then API key, that's it. And invoke is a function where you can use to write, to pass the prompts. Okay, and followed by we learned about components of LangChain, wrappers and prompt template. In the initial example, I mean in the initial stage, we are now still at the initial stage. In this initial stage, what we did, we just build a chain between wrapper and prompt template. Okay, how we just passed a prompt template. Okay, we just given a prompt. See, this is the way, like one prompt template. The same prompt template we pass it here as a prompt, and LLM chain is a function we are using to chain it together, both LLM and prompt. Is that clear? And then in the prompt template, how many dynamic variables are there? One, two, three dynamic variables can be observed with respect to the curly braces. Those variables we have to define in a dictionary way. Okay, so that is again invoke function only. From the beginning it is been common, and here also invoke function llm dot invoke means there you can pass the prompt, you will get the result. Chain dot invoke means whatever the dynamic variables are there, you have to provide them. For suppose if you don't have any prompt template, directly you can use llm chain and you can give the prompt. If you print this llm directly, you will get the result. Clear? Now another important thing with respect to RAG, okay, embeddings. Before going to RAG, just understand about these embeddings and semantic search. After that we will explain, I mean we can discuss, we can discuss about uh, RAG concepts. First of all, what are embeddings? This is a straight away answer. Embeddings is simple to understand. It is simply converting the text into high dimensional vectors. As we all know that it in NLP class also I told you, it will not understand the text. Anyway, it will convert those things into high dimensionality vectors. The process of doing this thing is called embeddings. But here what we'll do, it will capture, not only it is not only converting the text into numbers, it is also going to capturing the semantic meanings. What is meant by semantic? The similar weighted meaning. Okay, similar meanings in vectors. Okay, that is what it is doing. Similar meanings result in vectors close to each other in space, right? For example, you know, okay, if you want to understand this concept, just I would like to Google and will show you similar meanings. There is actually there, I don't I don't know whether it is still available in the images. There is an image actually, can show you this thing. Yes, it is there. Okay, you can see this one. I will open in the new window. Here you can see, yes. Okay, so all the semantic ones will store in single space. Got it? And here please refer this document, there you will understand. We already discussed about Manhattan distance, Euclidean distance, in the concept of k nearest neighbors. Okay, so nearest neighbors is nothing but, we know that whichever is nearer to that particular data point, it will go and assign to there. With the help of Euclidean distance we can find, Manhattan distance we can find. Okay, so it is simply what it will do, the embeddings means, now try to understand, it is going to convert the text into high dimensional vectors that captures the semantic meaning, which means whatever the words or the it is having the same meaning, that will result in the vectors which are close to each other, right? That is what we can call it as synonyms. In synonyms, what is happening? Synonyms relate same word, it might be different word but same meaning will come. All such words group at one place. Okay, so that is what it is saying, very close to each other. Those are all similar meaning results in vectors will close to each other. Okay, and then what is the difference between a search of from similarity and a traditional search? Okay, so understand this concept in two different ways. One is embeddings, that is what we just discussed. Embeddings means simply it will convert a text into high dimensional vectors that captures the semantic meaning. Semantic meaning means similar meaning. Okay, what is a search means, what is generally search? If we are searching something, okay, for example, if we are searching here itself, embed, we are searching, so we find something, right? So this is what a traditional search. Here you can see the same thing which we have given here. Traditional search means exact keywords it will match. But what is semantic search? Semantic search means it will understand the meaning and the context. Okay, for example, in your, if you go to the Google, if you search for something like what is analogy. Okay, so it got first traditional search the element we got, and then we got the similar meaning. Okay, if we go ahead, then we'll see analogy, what exactly analogy, analogy definition and meaning, analogy, and then these are all general search. But if we use synonyms, okay, similarity, similitude, likeness, resemblance, so these are all the common synonyms. All these words will have the same meaning, same context. Context comes from sentences. Okay, for example, in your childhood, you could have faced this thing in English subject. Actually, somebody might have asked you the what is the meaning of a particular word. You may not get it, but you if they say a sentence, okay, you will get the meaning of the word. Okay, the same word which you could not answer earlier, but you can easily answer once you know the complete sentence. The reason is, if you can answer straight away for that word, then you will get the similar meaning. Okay, you could have relate the same word with similar meaning with other word you are telling. If you also relate with the context, then you can easily answer what exactly that means. Is it clear? Is this clear what is exactly semantic search means? It will understand meaning and context and will fetch the results accordingly. Traditional search means it is just now I showed you here, control F if you type, okay, same things, whatever exactly matching, that will only get you. For example, vector, see, there are total 17 times I have vector, the same word. This is what traditional search. Semantic search means we also need to get the similar meaning of vector. Okay, similar meaning in
It's
vector. Huh? Any doubt?
no, no, no. I understood this one.
Got it. So, um, so now we use semantic search actually. Traditional search we need not to use, right? So all the time, all the people don't use the same words to describe something or someone. They can use, they have their creativity in their languages, and they can use different words, different ways to illustrate something. So we need to fetch those things from the internet or from anywhere. For example, uh, your intention is to fetch something from the internet. The same words may not be there in the internet, but conveys the same information in the other article. It will show you, right? That is what semantic search. We need that semantic search. Okay. So if you understand what exactly embedding, what exactly semantic search, then let us jump into the vector stores. Okay, before going to vector stores, now I will show you the RAG. So before RAG, just give me a clear like indication that you have understood till now what exactly uh, LangChain can do, and also the components of LangChain, and then this simple LangChain, LLM chain. Up to now clear what, and also embeddings and semantic search. Up to now is that clear? Hmm? Can I get that confirmation?
Yes.
Very good. So now we can see many images
So
of RAG architectures.
let me
Yeah, yeah. Any doubt?
tell you what I understood. Uh,
Quickly.
semantic and traditional.
You can.
So yeah, traditional is like it gives the exact search result,
Yes.
but coming back to semantic, it will give the exact result as well as similar results.
Exactly. You're true. So semantic
Mm.
search, the target is to fetch the similar things. It may not, sometimes it may not be the exact word which is there. For example, I do have proper examples also. See, here I have shown you, I will give you the proper example. Okay, but here the before going to that example, you have to clear yourself. Like semantic search means sometimes, as you mentioned, you are exactly right. Sometimes the same word may not be there, but still the similar meaning is conveyed with other word or other statement, that should return. Okay, you're right. Is that clear, everybody?
Yes, Ashwin. Yes.
Yeah, I hope Samreen and Maria also clear on this. Okay, fine. Going further, so just try to understand RAG architecture. RAG is something like an architecture only. You can remember that architecture, how exactly it is out of its architectural diagram. Then we will try to implement the RAG architecture one by one, so that you will never forget the RAG anytime. Okay, let me show you one proper thing. All are proper only, but what makes you easy to understand, I'm just figuring out. Um, all are valid only. Just give me a sec.
The is you're searching for the easy one, like the good one.
Yes, I'm searching for the maybe this. Okay. Huh. Okay, this is also easy and conveyable. Fine. Okay, so RAG is retrieval augmented generation. Why do we need RAG? Okay, why do we need RAG means I have provided here very simple statement. Oh, okay, I forgot to add, I think. Okay, forgot to add what is RAG. Okay, fine. Okay, we can get that information anyway from datacamp. It is also valid resource to search. Okay. Okay, what is RAG? RAG, why do we see RAG means retrieval augmented generation. Observe this one. It is a technique. It is a technique. What kind of a technique it is? It is that enhances the large language models by integrating them with external data sources. Just understand this thing. This thing is really important. Okay, retrieval augmented generation is it's a technique. Okay, with the help of this technique, what can be achievable means, for example, let me go to the chat GPT and will show you. Okay, so here for example, um, Prajwal, what is your university? What was your
Yes.
university?
UNT,
Hmm?
University of North Texas. University of
University,
North Texas.
University, University of North Texas, right? So who was the professor? I mean, what was the subject you have chosen there?
Information systems.
Huh? Instrumentation systems,
In,
right?
information, sorry.
Info,
Information.
IT, information
Yes.
systems, right?
Information systems.
Can you
Yes.
please
Yes.
give me any one of the subjects names?
Yeah. Data visualization.
Data visualization.
Data vision. Yes.
Okay. Which professor? I mean, who is the professor who teaches actually? Who teaches information? Sorry, data visualization, right? Data visualization subject. Who teaches data visualization subject in University of North Texas? Okay, control C, and if you type the same thing here in Google, let's see Google. Dr. Sharat Sharma is the same teacher taught you?
No.
No,
There will be a lot of professors issues.
obviously, correct, right? So Google don't
Yeah.
know who exactly taught, in University of North
Yeah.
Texas, uh,
Yeah.
that particular subject, right?
Yes.
It has might be
Yes.
the data which is long back ago. Okay, Dr.
Yeah.
Sharat Sharma might be one of the professors in North Texas who had taught the same
Hmm.
subject long back. That was the data
Yes.
that LLM had, or else the Google had. So if I ask the same
Yes.
thing into ChatGPT, it will show from the web.
Hmm.
It is searching from the web. University of the Texas. So several faculty members are there. So some of the faculty members are like Dr. Leni Boyce. I don't know how to pronounce them. Sorry. Dr. Sharat Sharma, anyway, one of them, and then Fariba, okay, Sarad,
Correct.
okay.
Mm-hmm.
So it has provided these many results, but it don't know, it doesn't know. Sorry, it doesn't know who exact the same who exact taught you the subject, right? Because it doesn't know the
Yes.
data.
Yes.
If you have your own
Correct.
PDF, if you have your own PDF,
Mm-hmm.
if you provide that
Yes.
PDF to, we need something, a technique. We need a technique. The technique in such a way, the question can be anything from the PDF. The question can be anything. According to the question, the technique should fetch the relevant result from the PDF and then use the LLM capability to answer it. Is my point clear?
Yes. Clear issue. Using the PDF by taking the reference of the PDF.
Correct.
Reference of the PDF.
Exactly. Now understand this one. What exactly RAG means? RAG, retrieval augmented generation, is a technique that enhances the LLM. Sometimes LLMs don't know all, but we do have our own data set with us. For example, company policies. Companies' policies are only known to the employees who are working in that organization.
Yeah.
It is
Yeah.
not
In
going to
particular
be
company.
published anywhere because those are their secret values. Those are their work ethics. All such things are
Yes.
only restricted to company. So the company policies LLM don't know. But in any one of your employee, for example, you are working for an organization. For example, let us consider you own your own company, like you have your own company. One of the employees or wanted to know any one of the policies in your company. So the employee need not to reach out to any HR or TR or something, CEO or something like that. You can build one LLM where the LLM takes the reference from your policy and answer that question. The question can be dynamic, right? Answering the dynamic questions of users, LLM support is required. But to the LLM, what data it should refer, not its own knowledge. Instead, it should refer
Yeah.
the document of us. I
Yes.
hope you are
But
getting me,
of that
right?
of our company.
Exactly. Now,
Yes.
now try to understand these statements. Retrieval augmented generation is a technique that enhances LLM by integrating them with external data sources. External data sources might be PDFs, documents, anything. Okay. By just combining the generative AI capabilities of models like GPT-4, Gemini, anything you can name, with precise information retrieval mechanisms. RAG enables AI systems to produce more accurate and contextually relevant responses. Okay, so LLMs also do have some limitations. One of such limitation is limited knowledge. Just now we have experienced, right? It doesn't know that who exactly taught data visualization subject in the university and particular semester, because it is having limited knowledge. So that limited knowledge can be achievable with the help of RAG by providing our own external data resource. And LLM also having another limitation is hallucinations. It can sometimes think something else it is true, but it might not be the true all the case. Such hallucinations also can be eliminated by using RAG. Okay, it is just like providing the LLM the right set of data from where it can actually gather the information. And then generic responses, sometimes it will give its own idea of promoting, right? But we all can stop such things with the help of RAG. That is why all these limitations can be effectively treated with the help of RAG. Okay, so I hope it is clear the understanding of RAG. Now it is very important to understand the picture of it. You can see. So what exactly the architecture is? Very easy architecture. User will ask a question. Okay, user will ask a question. We will have a data source. So retriever, we should need a retriever. That retriever, what it can do, it can search from the document and get the relevant text. So you searching and find searching, we have many things like traditional search is there, semantic search is there. But if we want relevant text, Which search can be helpful? Anybody out of these two?
So- Sorry, can you repeat that again?
Yeah. See, we need a retrieval. So, for example, if user will ask a question, anything can be asked user. We need a
Mhm.
retrieval. Retrieval will look the data source what we have and then fetch the relevant data. In order to fetch the
Yes.
relevant data, we do have two different searches. Traditional search is there, semantic search is there. Which search can be helpful here?
Retrieve the data. I think semantic search is
Exactly.
required.
Because
It will be using.
the user questions are dynamic in nature, can be asked with different keyboards also, which are not there in the data source. But we need the same meaning
Yes.
information out of it. So then semantic search. We use semantic search here to get the retrieved information. That retrieved information we will pass to the LLM. Okay. Along with the question, you can see the diagram. Along with the question, for example, question is who is Prime Minister of Narendra Modi and why he is the Prime Minister. It is the question. Okay. The answer of the question, who is the Prime Minister of the India, the direct answer can be available there in data source. But why he exactly the PM, that question answer may not be there in the data source, but LLM knows that. Is that clear?
Yes.
Okay, that is why here you can see query plus text. Both things should pass to LLM. According to the question, according to the relevant data, it will answer it is using its own knowledge as well as the proper guided knowledge.
Data.
Okay, so
The data.
then the responses will be provided to you. By using this RAG structure, what can you now tell me? What can you eliminate? You can eliminate the hallucinations, you can eliminate the generic responses. You will get the valid responses. You will not, the LLM will not get hallucinate with something else other than what required. Is that clear?
Yes, Ashwin.
Very good. So now you can see, this is a small example with respect to embeddings and semantic search. Anyway, I just told you embeddings. Embeddings means we can convert a text to vector. Remember that. Semantically meaning vector. Okay, we are converting, but from where we can store them? We can store using vector databases. Okay, what is the name of it? Vector databases. If you go ahead in Google and search for what are different vector databases, okay, we do have many vector databases, you can see, but the top is FIAS is one. FIAS is Facebook AI similarity search. Okay, Facebook AI similarity search. So it will do the operation of similarity search only. Okay, and here if we go down, okay, there are many actually. One is Chroma DB. Chroma is the name of the vector. DB stands for database. Chroma database is one thing. Pinecone is second thing. Waveweight is third thing. FIAS just now. This is what we are going to use now because it is free. Okay, Chroma DB also free, but it do have its own set of functions. We need to refer and then use it. Little complex, but it is also effective, especially for the images and all. Large data sets, Chroma is suggestible, but small is FIAS is enough. How it will do? You can see it will come up with an index. It will build index for a collection. Okay, indexing, it will do the data to the indexing and it will store indexing. The query, if any query comes in, okay, it will refer that which exact index is actually matching and then will provide you that results. Okay, it will use a nearest neighbors. Okay, nearest neighbors formulation. For example, if you want, see, this is a bus picture. If you want 5 relevant pictures of this bus, sometimes the same picture may not be available, but contextually 5 relevant things out of this, I mean from basing the bus image. Okay, if we want 5 relevant images related to bus, it can be something like motorcycle or else car, all such things are traveling modes on road. Okay, so similar. Okay, you the number is in your hand. Like for example, if you want 3, if you want 2, if you want only one exact similarly thing, that is can be described by the developer. Is that clear? It is simply, it is indexing and then storing in the RAM. You can ask any query, it will search for the proper index. How many indexes you want, like for example, how many relevant searches you want, you can mention. Accordingly it will fetch you that many relevant indexes related data and will provide you. Architecturally that is what. And other thing is called quadrant, and then milliverse and pg vector, and all such things are there. Here you can see the complete table, top vector databases comparisons. Okay, you in your free time please refer this so that you will understand which language you are using, what exact thing can be helpful to you. Okay, Fias, yes, Python can be useful, C++ can be useful. Okay, and mostly Python is there. You can see almost all Python can be supportable except this one. This you can avoid. This is quadrant. This is can be only done by REST. And PostgreSQL, if you know PostgreSQL, you can use this PG vector, Postgre vector. So for that you need to use SQL to fetch the relevant information out of the table. If you want to skip SQL, then also you can skip this. Better you can practice, start with Fias and then Pinecone and then Chroma. These are easy to use. Okay, but only difference is Pinecone you have to create an account and then API key also. Remember those things, and you have to follow their own way of steps. Fias does not require anything, just a library. It is directly straight away available in the LangChain. You can see langchain.vector stores import Fias. Similarly, if you go to the LangChain documentation, if you see ChromaDB, you can search ChromaDB related
I think
functions.
it's THROM, I guess.
Correct, you are right.
Roma.
You can see ChromaDB. Okay, Chroma related functionalities. Got it? Now it is now Fias we are using. It is simply, it is kind of a vector store. You can remember this concept is like it is a box. In that box you are converting all the strings into vectors, and then any question if you ask, okay, you will get the result. But you may have a question like, what model will help you to convert the text into numbers? Anybody has the doubt? Vector Fias will
Uh,
not convert into numbers. It is just storing. It is a database. It is kind of a database where you can store. But what actually going to helpful to convert text into numbers? That is what we have to pass again model. There are many models which can help you to convert texts or strings, an entire document into vectors. Effective things is sentence transformer from Hugging Face. Sentence transformer models. Okay, if you use this sentence transformer models, this is also an effective. And Google Gemini again, uh, you have to remember in such a way, Google not only providing you the Gemini LLM, also it is providing the embedding models also. Similarly, OpenAI also doing OpenAI embeddings and OpenAI LLM. Also Cohere LLM and Cohere embeddings. Okay, embeddings is something like converting the entire text into words, and those words we are going to use Fias to store them. If we ask any question to the Fias, so that will retrieve the vectors. That vectors again convert back to the strings and can be visible to us. Now is it clear? Hmm?
No, do it again real quick, Keshwan.
Yeah. You have to remember in such a way like embeddings means, you know the embeddings, what is exactly embeddings? Can you, if you understand?
Uh, I don't remember. Maybe I know, but
Embeddings means, this is an important concept. That is why I keep on asking you guys. Like embeddings means converting the text into numbers. Okay, not numbers actually, vectors. Vector of numbers, where each vector will store the semantic meaning of the thing. For example, lang chain. If we convert this into number, in general traditional way ASCII characters we have to use, right? But here we are not using that. Instead we use a semantic meaning of this lang chain. This concept was actually I taught to you in NLP lectures. In NLP I taught you word to vec algorithm. You can use word to vec algorithm. So if you use if you keep on building for semantic search, then embedding concept came. Actually it was in the earlier stage, it used to be word to vec, okay, identity density matrix. These are the algorithms which I already told you in NLP. You can refer in your free time, but in now you for a real quick, you can understand in such a way, like embedding simply like it will convert a text or a document of texts into appropriate semantic meaningful vectors. Vector means numbers. Okay, now is that clear?
Yes.
Okay, so
Yes.
okay,
It will.
once we convert text into numbers or semantical meaning numbers, where we can store them? Where can we store them? We can store them in a data store, vector store. That is why the name is vector store. Store means what? We can store something, right? So
Yes.
what are the different types of vector stores are there? I just given you the brief idea. Here you can see Fias is there, Chroma is there, Pinecone is there. All these are vector stores. Depending upon the language, programming language what you use, you can choose the vector stores. For example, if you are using Python,
Yes.
then you can use Fias, Chroma, Pinecone.
Roma.
These three are suggestible things. Out of these three, first I will strongly recommend you can start with Fias first. Okay, Fias is a Facebook AI research similarity search. Okay,
Sure.
but this is only going to store your vectors. The responsibility of Fias is whatever the embeddings you create, that will be stored there, and whatever the question you ask, it will do the similarity search, which means a semantical thing, uh, semantic thing or similarity, right? It will do the similarity
Mhm.
search
Yes.
and then fetch the relevant numbers, and when provide to you the numbers again further convert to the back to the strings and will be visible to you. Is that clear? Hmm?
Yes, Ishwan. So
now
it will
now it is understand that
store that and
what are the different models are there to convert the text into numbers. We can use Google embedding model, or else I just told you the sentence transformer models we can use from Hugging Face. Also we can use Cohere embeddings, OpenAI embeddings, Gemini embeddings. These are all the models. Okay, all these models intention is same, that will convert the text into semantical meaningful vectors. Now we are using Google one. Is that clear?
yes, clear, Ishwan. We are using the Google Gemini one. Yes.
Exactly. Now for the example purpose what I am doing is, here I am just taking three different texts in a small vector or a small list. Three different strings. Langchain, about one thing is Langchain. Another sentence is about embeddings. Another thing is Modi, is the Prime Minister of India. Okay, so now what I will do is, first of all I have to convert all this text into respect to embeddings. See, this is an embedding. If you print the embedding, you can see all the vectors. Let me print this. Okay, let me print this embeddings for you, and you can see the complete five dimensional. Okay, you can see API key got secured, and yeah, directly you cannot visualize the numbers if you use, by the way, yeah, if you use Langchain, it will not show you the direct numbers. But if you use it in with respect to Gemini without Langchain, you can see the complete vector of numbers. Okay, yeah. So now what we are again going to do is vector store. Now we are calling Fias is the one we use. From text is the function, I mean it is textual, that is why from text. All the these are the texts, and these are the embeddings. It will attach the indexes. Is that clear? I just told you how Fias works. It will attach the
Mm,
indexes.
yes.
Correct? So in order to find attach the indexes, we need to pass both text and embedding, so that one on one it will relate. Okay. Now I'm
Mm,
asking a
yeah,
question.
relate to
Exactly. Now
relate
I
to the respective.
exactly. Now I'm asking a question. Similarity search is an algorithm. Now I'm using that similarity search, and I'm asking a question. Who is the PM of India? The same word is not there, you can see, in our data set, but it will retrieve the relevant information which is there. How many relevant informations I need? Only one. That is what K. This is what I told you. Nearest neighbor algorithm will work. Okay? Is that clear? If I ask
Yes, clear.
if I ask anything other than this one, if I ask that what is LangChain, if I ask this thing, out of our documentation, okay, out of our documentation, LangChain contains only one specific statement, that is LangChain builds LLM apps. That is what will be retrieved you. Okay, it okay. It is not
Yeah,
answering.
got.
It is not answering out of this statement. It is only retrieving what exactly it is. Okay.
Yeah, like retrieving from the document.
Exactly. Now this is all about vector databases and embeddings, and I need exactly 10 more minutes of your time. So here this is the way how to store the
Good.
data, and then how to convert them to vectors, and then how to retrieve them based on a question. Okay, how many you want also it is defined here. For example, if you add one more section, which is India is a nice country. Okay, we do have two statements related to India, and embeddings and LangChain similar. These two are similar. These two are similar. Now I will ask a question like, who is PM in India? Okay, but instead of one, I will put two. Now understand. Now you can see two different things it got. One is India, Modi is PM, and India is the nice country. Now is it clear? It is relevant to these two. Hmm?
Yes, semantical search.
Yeah, it is all depend upon how many the scalar value, how much scalar value you have fixed.
Yeah, yeah,
Okay,
yeah.
now
Even that. Yeah.
yeah, now let us understand that how I already mentioned you, like we can pass our own data set either in terms of PDF, CSV, Word, anything. How do we can pass that our data? How can we convert our data to embeddings? How can we ask a question out of the data? How can we retrieve the information out of it? All such RAG implementation, let us see. See the supported, you should understand this thing. And remember also, that is why it is really important. I have, you should always remember PyPDF is what the loader you have to import. Anyway, we already imported in the beginning, and also we are importing here. Sorry, we already installed earlier. Now we are importing PyPDF. PyPDF loader for PDFs. Remember that unstructured PDF loader can be PDFs. There are two things: PyPDF, unstructured PDF. We use PyPDF. For Word documents, you should use unstructured Word document loader. This is the function. For Excel or CSV, you can use CSV loader or unstructured Excel loader. Okay, these are the things you should remember. Now, if you use PDF, now you can directly use PyPDF loader, and then you can pass the path of the of your PDF inside PyPDF loader, and then you can use a load function, and then you can see all the documents. If you use 0, the first thing will get reflected. First document chunk. What is meant by chunk? It is an English word only, right? Okay, it is having a small, this is path error. Okay, fine. So we can do one thing. We can copy this, copy the path properly, and then paste it here. Let's try. Yeah, this is just a path error. Okay, the path was wrong. Okay, so you might have heard about the word called chunk, right? What is meant by chunk in general? Hmm? Chunk means part,
Means
parts,
yeah.
right? Cut that into chunks. right? We use in phrases. Like chunk means part, the first part. Document of zero means the first part. If you don't use this directly, if you print, you will see all the document. Whatever the document I have, you can see all information. It is all the things. Okay. If you want only first part, then you can use zero. See, this is a whole document of me. Of course, you in how computer can understand the lines means slash n. That is why it is. Okay. So this is whole big document. This is all loading, loading, loading. So that is why instead of showing that all, we can go ahead and see zero. That means first chunk. Okay, this is first chunk. Okay, what is chunking? And chunking means, I just told you, why do we need chunking? Because LLM have limitation with tokens, right? LLM has a limitation of tokens. We want to retrieve, see, if we ask a question, in a document, okay, traditional search means it will only search the same keywords or statement or sentence in a document, but semantic means all meaningful thing is should return, right? In this process, if we don't chunk it, the entire document has, of course the entire document has a similar meaning. The entire document will go and pass to the LLM. Then what will happen? Tokens will get increased. If we have more number of tokens, there is a limitation. LLM cannot take it and handle it. We can divide the
Yes.
document into, let us say, 1,000 chunks. Okay, 1,000 small chunks. Then according to the question, which chunk actually has the proper information, that chunk only will get out of the document, and then will pass to the LLM. Is that clear?
Yes, Ashwin, it's clear.
Got it? So that is what it is called. Here you can see how many chunks I am forming. 100 chunks. Sorry, 500 chunks. What is this overlap? Overlap means sometimes what we happen, if we exactly cut the things, cut the entire document into exact characters, sometimes we may lose the information in here and there. That is why if we overlap, let us say 100 characters from the above chunk and take it out, and then again form another chunk, again leave the 100 characters again to the next chunk. You understand, I think, right? What is chunk overlap? And the function we use is recursive character text split. These are the functions that might be asked in interviews. What function will you use to chunk it? Recursive character text splitter. Okay, so this is the one we are using to split the data and then form the chunks. And then vector stores, how to store the chunk data means fires from document. It is a document. Earlier it was a text. That is the difference between this and this. Earlier it was text, but here it is document. That is why we have to use the entire document we want to store. That is why fires dot from documents function, and pass the chunks and embeddings both. And now memory concept. From here we can discuss tomorrow, because too much stuff it will be if I explain today itself.
Yeah.
It will get overloaded.
Yeah.
But till now
Can
this
you
is
also? Uh-huh.